A recent report claims the drone startup Xtend has secured $40 million to pivot from commercial delivery to military defense. This is a critical moment for anyone tracking autonomous systems. The real stakes involve whether this shift signals a fundamental change in how we build hardware or just another corporate rebrand. By the end of this discussion, you will understand exactly why this pivot matters for the future of engineering careers and funding landscapes. The story begins with a confusion that is common in this industry. There is no verifiable evidence of a drone company named Xtend securing $40 million for a defense pivot in the current data. There is an X-ray telescope named Xtend, and there are academic papers on autonomous weapons, but the specific news event described in the headline appears to be a conflation of different entities. However, treating this as a hypothetical scenario reveals a profound truth about the robotics sector. If a delivery drone company were to make this move, it would not be a simple marketing adjustment. It would represent a complete overhaul of their engineering philosophy and supply chain. Consider the fundamental difference between delivering a package and surviving in a contested environment. Commercial delivery drones operate in benign conditions where the primary constraints are battery life and payload-to-weight ratio. The goal is efficiency. You optimize for the cheapest route and the longest flight time. But military applications introduce a new set of constraints that demand survivability. In a defense scenario, you are not just fighting physics. You are fighting electronic warfare, signal jamming, and adversarial targeting. This forces engineers to abandon consumer-grade supply chains entirely. Because of this shift, the hardware requirements change drastically. You can no longer rely on off-the-shelf components that are susceptible to interference. You need hardened electronics, anti-jamming communication protocols, and autonomous swarming logic that functions even when GPS signals are denied. These military-grade components are not just more expensive. They often require redesign cycles that are 10 times longer than consumer products. A commercial drone might iterate a design every few months. A tactical drone system might take years to validate because every component must be proven to work under extreme duress. Quick resource note: I keep a curated set of Amazon search links in the description for books, gear, and tools relevant to this channel's topics. Some are affiliate links, so I may earn a commission at no extra cost to you. Please consider supporting the channel by using those links if you find something useful. This leads to the first major insight regarding the funding landscape. We are seeing a bifurcation in how capital flows into autonomous systems. Commercial delivery startups are facing diminishing returns. Regulatory hurdles are high, margins are thin, and the logistics market is saturated. Investors are becoming wary of pouring money into companies that cannot prove a path to profitability in a crowded urban environment. In contrast, defense contracts offer non-dilutive capital and longer development horizons. This encourages a dual-use architectural strategy. Companies are now building core autonomy stacks that can be repurposed for contested environments rather than just urban delivery. Here is the thing that most observers miss. The pivot is not just about selling a different product. It is about re-rating the company's entire asset base. When a startup moves from logistics software to tactical hardware, investors stop valuing them based on their fleet management algorithms. They start valuing them on their intellectual property in sensor fusion and autonomous decision-making under communication denial. This fundamentally alters the technical roadmap. The focus shifts from optimizing delivery routes to ensuring the system can make critical decisions without human input when the network is compromised. This shift creates a critical divergence for the professionals working in this field. If you are a data engineer or an ML specialist, your value proposition is changing. The industry is moving away from optimizing for efficiency in benign environments. The new demand is for robustness in adversarial environments. Expertise in fault-tolerant systems and cybersecurity is becoming a higher value asset than pure delivery logistics optimization. A model that can navigate a perfect city street is less valuable than a model that can navigate a jammed urban canyon. Consider the implications for the supply chain. The move to defense means sourcing components that are not just available but are also certified for military use. This often involves dealing with legacy manufacturing lines that have been dormant for decades. The cost per unit skyrockets because you are no longer buying in the millions. You are buying in the hundreds or thousands. This economic reality forces a rethink of how autonomous systems are designed from the ground up. You cannot simply scale a consumer drone to military standards. You have to rebuild the architecture to prioritize resilience over cost. The $40 million valuation mentioned in the hypothetical scenario implies a re-rating of the company's potential. It suggests that the market believes the future of autonomous systems lies in high-stakes, high-reward applications. This signals that future funding rounds will prioritize intellectual property that solves the hardest problems in autonomy. The era of cheap, disposable delivery drones is giving way to expensive, resilient tactical systems. This is not a trend. It is a structural shift in the robotics industry. Now consider the career implications for engineers. The skills that made you valuable 3 years ago are not the same skills that will make you valuable 3 years from now. If you specialize only in route optimization or battery management, you may find your opportunities shrinking. But if you develop expertise in sensor fusion, edge inference under jamming, and secure communication protocols, you will be in high demand. The industry is moving towards systems that must operate independently when the network fails. This requires a different kind of engineering mindset, one that prioritizes safety and redundancy over speed and cost. The confusion around the specific company name, Xtend, highlights a broader issue. The line between commercial and defense applications is blurring. Many startups are building dual-use technologies from the start. They are designing systems that can deliver a package today and support a mission tomorrow. This flexibility is becoming the key to securing funding in a volatile market. Investors are looking for companies that can pivot quickly when the commercial market stalls. The strategic pivot highlights a critical evolution in how we think about autonomy. It is no longer about making things faster or cheaper. It is about making them reliable when everything else is failing. This is the defining challenge of the next decade. The companies that solve this will define the future of the industry. Those that do not will find themselves left behind in a market that is rapidly consolidating around high-value, high-complexity applications. The signal is clear. The future of autonomous systems is not in the last mile of delivery. It is in the first mile of defense. This shift is reshaping the hardware, the funding, and the careers of everyone involved. The companies that understand this transition will be the ones that survive and thrive. The rest will be left to wonder why their models worked in the lab but failed in the field. Thanks for watching all the way to the end. I am a one-person team working hard to make each video better than the last. Subscribe if you found value. It is the best way to show support. Drop a comment with your biggest takeaway. See you in the next video.